Hello, and a very warm welcome to all the people attending this webinar today on how to build a career in artificial intelligence, a very critical question of the current era. We all know that AI, although will be profoundly changing the jobs landscape in currently or the next 5 to 10 years, the crucial question that needs to be answered is what should an engineer or a manager do today to build a successful career in this new landscape, and what actions or critical actions they need to take. To answer this critical question, we have organized this hour-long webinar session with an esteemed speaker from the SP Jain School of Business Global Management, Dr. Debashish Guho. He's the Associate Professor and Director, Master of Artificial Intelligence in Business. And today he's going to talk to us about how SP Jain's Master of Artificial Intelligence in Business can help professionals build a successful career in artificial intelligence. The webinar outlines how SP Jain's Master of Artificial Intelligence in Business course fits into this framework and why this makes graduates of this program very likely to succeed in AI-related careers. Dr. Debashish Guho is a leading expert in business cycle forecasting using the leading indicator method with extensive knowledge of quantitative and statistical methods. And that's why he would be the right person to guide us through this. The session will also have a Q&A, so start dropping your queries on the questions tab. And without any further delay, I would like to welcome Dr. Guho to this webinar. Over to you.
Thank you, Ms. Das, and welcome to everyone. We are going to talk about how to build a career in an AI world. Now that, of course, is a very general type of topic and could mean many different things. I have for you, however, something that, if you are expecting, practical tips on where to apply for jobs, then this is not the right place. What we are going to do here is going to think about how to construct, how to build a career given the trends in AI that we see and applications of AI that we see today, how things are going to pan out over the next 5, maybe even 10 years. And that is how we are going to approach this problem. So what we will do is we will first lay out a framework of how to conceptualize this problem, a theoretical framework, if you will, of how to think about it. And then we talk about how we have applied that framework in constructing our own Master of Artificial Intelligence in Business program. And we'll finish with some details about how the program actually works and why we think it's something that will set you on the right path to build a career in the AI-driven world that we all see coming in the next decade or decades. So can you see my screen, or what is the?
It's all good. If you want to do the full screen.
Okay.
Yeah, we are good to go.
Good to go? You can see the slide?
Yes.
Okay. So we will start with a definition. What is this thing called artificial intelligence? We talk about it all the time. What is it all about? Of course, it is about intelligence that is artificial, but it has a specific operational meaning. The operational meaning, as given, this is taken from Russell and Norvig, is considered the Bible of artificial intelligence, is to design agents that can perceive their environment and can carry out a plan of action in order to reach a goal. So for instance, talking about, say, a computer vision task. Let's say that we are given this task of monitoring a webcam system, a CCTV system, not a webcam system, a CCTV system, and look for intruders into a space. So we need the cameras, and possibly we need audio detectors to perceive the environment. And the goal is to detect and maybe raise an alert if there is an intrusion. And the plan of action is to uh, feed all the data coming in from the webcam into an AI system and look for anomalies that look like intrusion. So that is artificial intelligence, an artificial intelligence system. And this is what we call a narrow artificial intelligence, something that is designed to carry out a very specific task. So how this task break down? There is, of course, data. In this case, the data that comes in from the CCTV and possibly from mics. Uh, and this data is fed into an AI system that predicts something. This prediction is that of an intrusion, some intrusion that has already occurred or is in the process of occurring. And that prediction leads to an action. This action could be the dispatching of a law enforcement agent. It could be raising an alert, and this action has an outcome. Hopefully, the outcome is on the lines of what we are trying to do. For instance, it's not a false alarm, that there is, in fact, an intrusion. And this outcome then is fed back to the prediction engine as to whether the outcome was a positive one. On top of this, there is a question of judgment, and that's what we will talk about next. That in some cases, the process is not entirely automated. The process we described was a completely automated process, but it may not be a completely automated process. For instance, the prediction may lead to an alert, and then the law enforcement agency or the protection agency may decide whether an intervention is required or whether this is a false alarm or this is an intrusion that does not require an immediate intervention. And that is left to the judgment of the protection agency or the law enforcement agency that employs its own judgment to respond and to determine what the complete terms of the action would be. So any business task also has the same structure. There is data that comes in from the environment. Say that we are talking about a shop floor where there's some production. This production has human workers and robot workers. They're all relaying in data. This data then goes into a prediction system and it suggests certain actions. This action may be to shut down a machine because it's not behaving properly. It may be to bring a machine online because it needs more production, and that requires not only a prediction from a data prediction engine, but also judgment. And it all is fed back into the prediction engine and the judgment engine. The judgment engine usually is a person. And that is the entire structure of business tasks or in general tasks. And this could be a completely automated task in which there is no judgment, or it could be completely manual task where there is no data-based prediction engine. And the human makes the call based on their perception of what needs to be done. So this is a hybrid. The picture that we have here is a hybrid network, a hybrid process where there is both a human and a computer, but it could be a completely automated computer process or it could be a completely non-automated judgment process using manual decision making or human decision making. So what do we mean when we say the word prediction? What we mean here is prediction is the task of recognizing hidden patterns in data using what are usually statistical algorithms, although other types of algorithms are also possible. Fully deterministic algorithms are also possible, but mostly the algorithms tend to be statistical in nature, and the goal is to predict an outcome. So again, the prediction task itself has the structure of the task breakdown that we showed, that it takes in data, and this data has hidden patterns in it. Usually this is large amounts of data in very high dimensions, so that the task of recognizing hidden patterns is not a trivial one, and advanced statistical algorithms need to be used to recognize these hidden patterns. And the goal of recognizing these patterns is that these patterns tell us what the outcome is likely to be. So if you look at, for instance, going back to the example that we just talked about of intrusion detection, there is a certain pattern in the data that is that of a no intrusion pattern, and then that the pattern is disrupted, and this disruption is what you're trying to detect. And this disruption can be a natural disruption or a disruption caused by an intruder, and that is the goal of the pattern recognition task. The data is either numerical to begin with, so it could be like financial data, stock prices, economic data, things like that. It could be engineering data, readings taken on a machine, velocity and position from a drone, things like that. Or it could be data that is not inherently numerical but can be represented as a numeric matrix of some sort. So, for instance, an image is made up of pixels which all have values. So the actual image is being represented as a two-dimensional array of numbers. Texts also are represented as numerical arrays in artificial intelligence. So the data usually would be presented as some kind of a because it's digital computers that we're talking about. These are numerical data. And when we say outcome, we don't necessarily mean something that is going to happen in the future. It may be something that has already happened, but is not detected yet. So again, going back to the example that we just talked about, the intrusion may have happened already. Some intruder may have broken the boundary already, but has not been detected. And therefore, we use the term predicted, but we don't necessarily mean prediction of a future event. So some examples. In finance, a prediction may be whether a loan will default. So somebody has applied for a loan. We look at their credentials, their job, their salary, their past financial history, their other features that may have a bearing on whether the loan will default, and we make a determination as to whether the loan is likely to default or not. So this is something that is a prediction of the future, because the loan obviously has not been granted and has not defaulted, but it's a prediction in the true sense of something that will happen in the future. Similarly, human resource application would be where you're trying to recruit a new employee, whether that new employee, how well they will perform. That's again a prediction of the future. Marketing, whether a prospect will purchase an item, and in production, whether an equipment is going to fail, say, in the next week. So these are all examples of predictions of future events. But predictions can be of current or events that are in the immediate past. In healthcare, for instance, we want to predict whether a patient has a certain disease based on tests, based on symptoms, based on examination of the patient. We want to predict, that is to say, diagnose a certain disease. Obviously, the disease is already present, so the contraction of the disease has happened in the past, and therefore, but it has not been detected. So we still say that it's a prediction task, but the prediction task is now for an event that has already occurred and has not been detected so far. Similarly, when you're talking about credit card fraud detection, you want to do it in real time, but the transaction has already been initiated. So this is something that that is a prediction of an event that is in the immediate past. And similarly, forensic AI may be of an event of a crime that has already taken place or is ongoing. As opposed to prediction as we have described it is a data-driven algorithmic pattern recognition task. So it's something that a computer does much better than people. Obviously, we are no match for a high-powered computer when it comes to looking at large amounts of numerical data, possibly in more than 3 dimensions, and finding hidden patterns in it. a computer is going to be better at it than we are. So prediction and prediction type tasks are the domain of AI, of uh, AI statistical algorithms. However, there is another type of input to any task process, and that is the process of judgment. The judgment is the act of making complex decisions, taking into account predictions of key variables. So you do have predictions, but these predictions are not sufficient to arrive at the correct or the most appropriate decision. So what you want to do is look at these predictions, enumerate possible actions, because you may not even know what the possible actions are. And for instance, again going back to the intrusion problem, and this intrusion may be into a computer system. You don't know what the possible actions are. It may be dispatching a force. It may be uh, to sound an alarm. There may be various actions that have not been enumerated already. Estimate outcomes in light of predictions. Is the outcome the appropriate one? Is it too much? Is it too little? Is it not even right? And determine ranking criteria for outcomes and select the best outcome, and possibly in some cases more than one outcome, because you are able to take more than one action at the same time. So this is the action of judgment. And as you can see, these judgment type tasks, judgment type variables, are much more difficult for a computer to carry out. Judgment can also mean uh, in the domain of empathy or affect. So as we will describe in the next slide, judgment can also mean not just decision making, but actual empathic connection and something that requires affect. So judgment versus prediction, and some gives you some examples. Diagnosis is a prediction task based on data. This data comes from tests, it comes from symptoms, it comes from physical examinations, but these are data. And choosing, and then based on this, diagnosis is done. Humans still are somewhat better at complex diagnosis than machines are, but this edge is not going to last very long. In another 5 years, maybe even less, medical diagnosis is going to be an AI task. However, choosing between different treatment options and actually administering a treatment regimen is a judgment task. So you don't know what the possible treatments are necessarily, and what would be appropriate for a specific case in hand, because that's a very complex decision to be taken. And even more complex is to work with the patient to make sure that they are subscribing to the regimen, carrying out the activities that you prescribe for them, and that actually taking the medication that you prescribe and the treatment regimen, and they're not falling off that regimen. And that requires monitoring and empathic connection that is clearly beyond the ability of current computer systems. Similarly, hiring can be based, recruitment can be based on predicted performance, although this is still quite difficult. AI is still not very good at it, but one can imagine that AI will be good at it because it's a prediction task. But team formation and team management are clearly judgment tasks that again requires people skills. Similarly, in sales, prospect list formation is very much a prediction task, and it's done by AI right now, currently. But if you're talking about a complex, big ticket sale, that's a major project, and clearly is a judgment task that requires human intervention. And here we see that there is a pattern to this whole process. What we see is that when we talk about judgment, we're still talking about pattern processing, of understanding hidden variables and hidden patterns, but at a level that is not accessible to explicit enumeration. So what we are talking about is implicit pattern recognition versus explicit pattern recognition. When we say explicit pattern recognition, we mean that we have the data, it's all numerical, you feed it into some sort of a pattern recognition black box, neural network, something, XGBoost, something, some kind of machine learning algorithm usually, and outcomes, some kind of an outcome that tells you what to do or how to think about it, what class the data belongs to, what regression output is, some kind of a prediction of a currently undetected or a future event. Judgment, in many ways, does similar things. However, it is at an implicit level. And the skills required to carry out a judgment task have not been explicitly formulated. It is implicitly formulated in the mind of an experienced practitioner. And that is the difference between judgment and prediction. It's more a difference of degree than a difference of kind. And what we see is that the progress of AI has made many tasks which in the past or right now require a lot of judgment can be turned into data-driven pattern recognition tasks. I'll give you an example. In the last century, playing chess used to be considered an expert, behavior that only human experts can do, and the process that they bring to bear on this task is implicit, and usually they cannot explicitly describe the rules that govern this task. If you've ever talked to a chess expert and asked them how they arrive at a certain uh, move, usually in the end game they can give you a clear answer of what leads to what and why they have chosen the move. But in the middle or the opening game, often they will give answers like this looked right or that is not a good move, and they have intuitively and implicitly arrived at the answer, which is often correct, but they cannot make it explicit. And this is true of all judgment, all tasks that are carried out through intuitive judgments. And the progress of AI, however, means that this chess playing now has become an explicit pattern recognition task that computers are very good at, and no human can beat the best computers, chess playing computers in the world, and that is true also of other games like Go and poker. So the progress of AI has meant that the central task in all AI system development is actually to take a task that is informally and intuitively defined, and it requires the use of intuitive judgment to solve, and you reformulate it as a systematic and a quantitative pattern recognition model that can be analyzed using an algorithmically using a statistical algorithm or an AI algorithm. So the whole idea of AI development is in fact to turn judgment tasks into prediction tasks. However, this process of actually converting a judgment task to a pattern recognition or prediction task is itself a task that requires judgment. So this framework is going to help us in situating ourselves in the AI context, in the AI world. Where do we want to be? We don't want to be in a job that AI can take over quickly. That is the dread that all of us have, right? That whatever we are doing, AI can do better, so we will be all left without a job. What we're saying now is that certain tasks are already uh, something that AI does very well, and people are not going to be better at it than AI. And this has been true even before AI came to the fore. For instance, simple calculation, arithmetic. Obviously, no human can hope to do arithmetic faster than calculators or computers, unless a few freak geniuses. But that we have accepted that computers are going to be faster and better at calculations than people will. And not all tasks require calculation. and therefore there are a lot of things that we still can do. However, more and more it seems that there are a large number of tasks, and I'll give you an example. One such task is reading X-rays. Now, reading X-rays, people are still slightly better than radiological AI, but that advantage may not last very much longer. And this is a perfect example of a task uh, that AI is likely to be very good at. So if you are going to be going into medicine and you are going to be a radiologist, then you maybe want to think twice before you choose that option. However, if you are going to be, say, a pediatrician, then that's a completely different set of uh, tasks, and that will require a lot of judgment still, and cannot be completely and explicitly enumerated and delegated to an AI. So the idea is that although the process of AI development is taking over judgment tasks and converting them into pattern recognition tasks all the time, and that is in fact what AI development is all about, there is still a lot of opportunities for people to fit into this process and to fit into the overall task process, overall business process, and play a, an important role in this entire process. But you have to pick your spot right. And this is where we're talking about where career planning should focus on. Not whether you want to learn Python or R, whether you want to take up this platform versus that platform, because those things change all the time, and also those are not the most important issue when you're trying to build your career over the longer term. What you're trying to do is to situate yourself in the right part of the landscape. That's what you're trying to do. You are not saying that, okay, Python is more popular than R, so I know R, but I must learn Python. Okay, that is in fact true, that more and more Python is taking over tasks that used to require the knowledge of R. I certainly don't want to go into the Python versus R debate here, but that is just what is happening in the AI world now. And but those are decisions that are easy to take. And requires only a little bit of googling to find. However, what you really want to do is to find out where in the AI landscape you want to be. Do you want to be in the engineering part of the world? Do you want to be in the business part of the world? Do you want to be somewhere in the middle? And this is what we are talking about. And some examples that we are given is, interpreting X-rays, playing chess and Go, loan application evaluation, credit granting. These are all examples of judgment tasks. There used to be credit officers. There still are credit officers whose whole job is to evaluate loan applications. More and more AI is taking over this role. So what we see, however, is that the way AI is going to take over the entire business landscape that people are worried about, the way AI is coming to the fore in terms of how it plays a role in applications in the business world, is that first you start with a business problem that needs to be recognized and defined, even if it's only an implicit way. Once that is done, then this implicit characterization of the problem needs to be formulated in an explicit and even mathematical or statistical way. Once that is done, then you need to do the data engineering, the data cleaning, the data exploration, the initial modeling. So that part is the engineering part. So on the left-hand side, the orange box is the business part. The right-hand side, the bluish-gray box, is the engineering side. What you really want to do, and as we will see in the next few slides, is that you want to be in the middle. You want to be in the middle where you interpret and you transform business problems into AI models. The best place to be is neither in the business part of the process not the purely engineering part of the process, although there will be a lot of opportunities for people who are in either on the left-hand side box or the right-hand box. But in the long run, as we will see, both these boxes are going to shrink in size, and the middle box, the center box, is going to grow bigger. The problem of recognizing and defining business problems, the whole task of recognizing and defining business problems in an intuitive way and giving and taking and monitoring the process and coming up with problems to solve is something that is very important in today's world, but perhaps is going to decline in importance over the longer run. The right hand side of developing the correct engineering of data and the pipeline that feeds the MLOps pipeline and the machine learning or AI algorithms that actually solve the problem. These are all engineering problems that need to be solved, and you need a lot of technical knowledge that you bring to bear to solve these problems. And again, we will see, and I will explain why this is probably also going to shrink somewhat in the years to come. The middle part is the one that's going to stay and probably go bigger. The first question is business problem recognition. What do we mean? Well, I'll give you two examples. One is churn, where how do we stop subscribers from porting to another service? A question that telephone companies are always asking. Second question may be that of fraud detection. How do we detect fraudulent transactions, fraudulent credit card transactions in real time? Another could be diagnosis, where you try to find out. We talked about it already. Detect a disease using tests and so on. And in a business setting, for instance, the churn problem was detected by managers, and the managers monitor what's going on in their business, and they try to identify and define problems that they need to solve. However, what is happening now is that as AI gets adopted in more and more businesses and more business functions, the actual detection, identification, and definition of business problems is becoming more and more automated and AI driven. Again, give you an example. Used to be that Toyota had this process where quality control involved workers on the assembly line who would report defects and problems that was taken up quickly, and Toyota gained an edge over the whole automobile industry through their quality monitoring process that involved the workers into the process. As the production floor becomes more and more mechanized and automated, and robots do more and more of the work, what is happening is that the relaying of data from the floor to the detection system is becoming fully automated, and detecting and identifying problems is becoming an AI job. And this is happening more and more in more and more industries. The bottom level of actual operations is becoming AI driven, and therefore the data is getting relayed to the upper levels of the hierarchy much more quickly, and the decision making is becoming more and more automated. So what will happen is that the actual process of detecting and identifying and defining business problems is going to be at a much higher level, that is to say, not at the operational or even the managerial level, but maybe even at the strategic level, maybe a little bit at the management level. And the scope of working in those areas is going to be limited to a much smaller, and the middle management is going to shrink, and top management is probably going to get its feedback directly from dashboards that connect to automated data feeds. So you can see that there are not as many jobs that are going to be available, because the whole middle management layer, whose job was to identify problems and solve them, is going to be largely redundant in an AI driven world. Similarly, we see that in the data and AI engineering side of the process, the actual task of building data storage and retrieval systems is going to be, done is still done by engineers, of course, but more and more automated methods of data modeling and algorithm design are coming in. There is already systems that can write Python code, JavaScript code, and one can see that this engineering and model building is going to be perhaps fully automated in the future. So what you want to do is to be in the middle. The translation from implicit to explicit, translation from an incomplete definition of a business problem and making it a fully explicit and quantitative model is still going to be a core task for humans for a fairly long time. And if you want to future proof your long-term career prospects, you should maybe focus on this center box and build your career around it. And this is exactly what we thought when we designed the MAIB program, the Master of Artificial Intelligence in Business program. We focus on this central segment. We start with the foundations, which is mathematics, data science, Python ecosystem. Next, to learn the fundamental method. As you can see, this is engineering, and engineering is still very important. We don't have the tools to automate engineering yet, but maybe in the future we will. The second year, we start applications of AI to different business functions. And there will be a semester-long business project. There will be a semester-long capstone project. There will be multiple other projects. And projects are where you learn this translation skill. Take a business problem. You want people to actually take practical problems, and they're already doing it, and learn this process of turning a practical problem that is not fully well defined and converting it into a fully defined model. So the projects, that's how we do a project. In term 4, there will be an applied business project. There will be numerous other projects. For instance, we're teaching deep learning now. Several people are working on projects that are real life projects. For instance, one project that one team is working on is to take satellite images of agricultural fields and build crop yield prediction models. Similarly, another is working on a project that was suggested by an finance industry professional of certain pattern recognition tasks that used in stock market trading. There is a marketing analytics real life problem that some student teams are working on. So all of these projects are meant to develop this core skill of how to take an not completely specified, not completely explicit business problem and formulate a very clearly defined AI model and to actually carry out the engineering required to solve and create software that handles that problem. So some highlights of this program, most of our faculty are industry veterans. Many of them are industry veterans. If they're not, usually they are academics that have substantial consultancy experience, so they can actually tell you how this whole process works. Many of them were in doing precisely this, of taking business problems and building AI models to solve these business problems. We try to bring in at least once a month a leading industry executive who talks about their experience of how to apply AI in industry and what problems they face, how they solve them, the practical issues. For the, looking at the longer term in career building, we do have a placement cell that will help you find internships and placements. And what we also try to do is we get a very diverse background. Students of very diverse backgrounds. Some of them are engineers, some of them are management background. Some of them even have science backgrounds. Some are freshers, some have fairly long experience. So what we try to do is to tweak our whole program to fit the backgrounds and the career goals of each student. So we mentor each student separately. Our faculty mentor each student separately so that they take the electives that are more suitable for their background and their career goals. And also, we help them select projects that are most suitable for them. So, with that, I will stop and we can go to questions. Any questions?
Yeah. Hi, Dr. Guho. Yeah, amazing session. A lot of things to learn from this entire presentation that you just gave. And yes, we do have a few questions. If you want to quickly take them up, or
Yeah.
I can read them out to you.
Yes, please read them out. I can't see all of them. Yeah, please read them
Definitely.
out.
Definitely. Osden is asking, this is the first question. Hi, searching for AI to solve dynamic route mapping in geospatial analysis. Any idea where to begin with?
This is a classical problem. It's we call it an AI problem these days, but this has been something that operations research people have been doing for a long time. The dynamic routing problem is essentially the traveling salesman problem. And there are standard methods. It's an NP hard problem. Actually, it's an NP complete problem. So that there is no guaranteed polynomial time algorithm for it, but there are all kinds of hacks, if you will. I would suggest you to look at is like a huge literature on this. On which exactly dynamic routing? Can you read that again? Which dynamic routing problem are we talking about? In what is the context? Dynamic routing problem in? Can
In
you read that again?
yeah, in geospatial analysis.
Oh, geospatial analysis. Okay. Yeah. This is this could be the depending on exactly how it is formulated, it could be what is called the so-called postman problem or the traveling salesman problem, and there could be other versions of this problem. Uh, the operations research literature is the best place to look for this. Although in recent times, even AI people have done a lot of work on this.
Okay. Thanks, Dr. Ho. I hope that answers Osden's question. Moving on to the next question, we have a question from an attendee. Hi, can you tell me the skills required to succeed in an AI career? Also, what will make me a better professional than any other?
The skills required right now are, of course, Python and its ecosystem. Complete fluency is required in that area to hold down an AI job. This may not last. Things change, but right now that is the what and you in the most important packages that exist in this ecosystem. Obviously, the basic ones, pandas, numpy, but also PyTorch, which is becoming more and more important. Other platforms are also important. Database, data engineering skills are very important. So not just SQL, but NoSQL, uh, graph-based databases. Those are becoming more and more important. XML is sort of starting to be used. So if you're talking about computer skills, these are very important skills. However, as I have outlined in my presentation, the skills that maybe are even more important than just computer skills is the skill to understand something that is kind of vague and not entirely completely specified, and give structure to it and write down a model, and a model that you can code in Python eventually, or maybe not you, but somebody can code in Python eventually. That skill is actually even more important than Python coding skills. But the fact is that in an AI world, Python coding skills are absolute necessity, and we place a lot of emphasis on learning not just Python coding, but the entire Python ecosystem. Now, how you can be better at it? you can be better at it because, like I said, you have to understand the whole process, not just, the engineering part of it, and not just kind of the vague business type part of it, but the translation, the mapping, if you will, of, you know, let's say we're talking about the churn problem. The churn problem was originally about telephone company subscribers who are porting from one company to another. But now
Correct.
churn, the problem turns up everywhere. Uh, the the clothing company Gap, for instance, uses churn models for people who were shopping a lot on the Gap website, but now maybe they have gone over and they're shopping somewhere else. So that is
That's
also a
correct.
churn problem, but it's a completely different setting than the original setting, which was a telephone company problem. And churn could be of employees. Many HR people are using the churn framework to look at employee churn, not subscriber
Yeah.
churn, but employee churn. So you have to understand that the business problem comes kind of vague and not fully formed. And you have to say, oh, this is nothing but a churn problem. And okay, I have a solution for the churn problem. I have a solution for the like the dynamic routing question that we just saw. What is dynamic routing? Dynamic routing mostly is traveling salesman, but it could be something else. The question is, can I take that particular, and we have to know the exact details, and can we write down a, a statistical or mathematical optimization problem around it? And that is the skill, I think, that is going to serve you in the best stead in the long run.
Very nicely described. I hope that helps a lot to the attendee. Moving on to the next question. This is from Abhay. He is asking, hi, sir, how could you tell us some research problems in the field of medicine? Are there only most engineering tasks or some research tasks are also available?
There are like a whole host of research tasks in medicine. Medicine is one field which has taken up AI in a big way, a very big way. For instance, I'll describe one problem, and this is considered a graphical learning problem. Graphical learning problem in the domain of medicine is that there are molecules, you want to develop new molecules, right? That's one of the fundamental tasks of the pharmaceutical industry, to develop new molecules to fight diseases. Now, this is a chemistry problem, right? This is a biochemistry problem. So the chemistry problem is to actually find out what molecules bond with what molecules. What is the bonding energy and how do they bond geometrically speaking? This can be expressed as a network design problem. And there is a famous task in a Stanford University setting of this was actually a research task of taking a network where you know some of the values, some of the bonding energies, and some of the bonding geometries, but you don't know all of them. And to find out how the molecule will be structured and whether to look for a specific type of molecule and whether to even engineer, if you're talking about biotech, that molecule, how much energy it will take, whether it will be stable, and things like that. So this is at a very fundamental level a problem of, and then another major research task that is going on now is in the field of oncology, cancer. Now, several cancer researchers have suggested that the progress of cancer in a human body should be thought of as a large-scale dynamical system and uh, modeled as a network of cells that evolve in a certain way over time. And the job of curing cancer, if you will, is to disrupt this network. And can we take out parts of this network using nanotech or something like that when the whole network collapses. This is a machine learning task. This is a graphical machine learning task. And so there is a huge amount of work, and there is a work on nutrition, like, most of the micronutrients that we know about are not fully mapped. So you need to construct a knowledge base of what nutrients uh, do what in the human body. And we know only sort of vaguely this. And Professor Barabasi at Northeastern is leading a project. He's a network science, network learning professor, researcher, and he's leading a project, I think, for a major pharmaceutical company to identify and create a knowledge base of all micronutrients, and there are hundreds of them, and to completely map what they do in the human body. So these are just three examples of the use of research, and research that requires a lot of fundamental research uh, in the field of medicine.
Thank you, Guha. That's a very detailed answer and a very interesting question that has come up. Moving on to the next question. This is from Anirudh. He is asking, how can a professional with zero experience in artificial intelligence get into AI jobs by doing courses? And how does the industry treat such professional interns in terms of roles and responsibility?
Well, see, this is a function of demand. Used to be, and supply. Used to be that a 6-month course, sometimes even taken online, would be sufficient to get you into the field. More and more, that's no longer true. Employers are looking for an undergraduate degree, postgraduate degree, in some cases even a PhD, before they will hire people into the roles that they want. Typically, they want at least an undergraduate degree, but there are not that many undergraduate degrees in the field of AI. They're not. I don't know of any institution in India, for instance, that actually gives a AI major. And in the US, for instance, only Carnegie Mellon gives you a bachelor's in AI. MIT, Stanford, none of them have that. So your best bet is to get a master's degree in AI. And typically certificate programs are, now mostly employers are not going to get you uh, hired with only say a 6-month or even a 12-month certificate. 12-month certificate may be enough, but certainly not a 6-month one. And I think that more and more the industry is going towards hiring people with formal degrees. So it doesn't really matter if you don't come from a computer science or AI background. We've had a lot of success with people who came from non-computer but engineering, or even non-engineering backgrounds. What you need to have is facility and skills. So it's, if you have computer skills, coding skills, that's good, especially Python. Python you can learn online, not difficult. It's supposed to be one of the easiest languages to learn. And you need to have math skills, college level math skills. We're not talking about advanced mathematics, but college first year type math skills. But what we find is that even engineers, after they have left college for a few years, their skills get rusty, and faced with simple calculus problems, sometimes they cannot solve them. So it is essential at the present state of development of AI to have very good math skills. If you have that, then the fact that you don't have an AI background is not going to make any difference. You can get a master's degree and enter the field. And once you have that master's degree, then whether you studied mechanical engineering or physics or whatever in your undergraduate is not going to matter a whole lot.
Correct. Okay, great. I have one question from Sunil, very related to the course that we are talking about here. What is the difference between MAIB program and the MTech programs of AI ML in BITS Pilani and IITs?
I am not entirely familiar with these two programs, but my guess is that those programs focus on the engineering aspects of AI, because these are MTech programs offered by leading engineering colleges. So this is going to be mostly about the engineering aspects of AI. So we're talking about programming, of course, and in detail, software engineering, and which is very important actually in AI engineering, data engineering, and the whole host of those things. What we teach is, like I said, in the center box. We are not all the these courses are all the way to the right, MTech, and on the left is MBA. Most MBA programs are going to be about business management,
Correct.
and most MTech programs are going to be about the engineering part of it. We are in the middle. That's why we are AI in business. We're talking about, obviously, we don't leave out the most important aspects of AI, but there are parts of what an MTech in AI may cover that we don't cover. For instance, we give only an introduction to databases, not detailed look into data engineering. Similarly, we have some software engineering, but you're not going to get a full, rigorous, training in software engineering. Now, these are important skills to have for people who are going to be in the engineering part of AI. But what we want is to make sure that people do understand the engineering aspects, but they develop the skills to take business problems, formulate them, and maybe hand them over to the engineers, hardcore engineering types. You know, we are not still at the phase where engineering can be done completely automated. We still need a lot of human engineers to get the job done. So there is a lot of demand for AI engineers, and the programs at BITS, Pilani, or at the IITs, I'm sure, address that need. We're addressing a different need because we're a business school, first and foremost, and our history is that of a business school. But what we realized is that the business part of it has to be augmented by technological knowledge. Purely management knowledge is not going to be sufficient to operate in today's AI-driven world or tomorrow's AI-driven world. So what we have here is kind of a combination of the engineering skills and the management skills. And that's why I keep saying that we are in the middle, the center box, where we understand the business part, we understand the engineering part, and we understand how to put those two parts together. That's what we want our students to be.
Very nicely described, Dr. Guo. I have another question that could be related to this course. Anurag is asking, is it feasible to switch to AI after 15 years of work experience in software engineering? Also, I would like to understand, can a person with 15 years of work experience in software engineering join this course?
The answer is yes and yes. Yes, certainly somebody with 15 years, we would very much welcome people with 15 years of software engineering experience. You would be a very good fit for the program. Of course, there will be a huge difference between you, who has 15 years of experience in software, and somebody that's coming fresh off of a economics degree, undergraduate degree. You are not going to get the same jobs. You probably should not take exactly the same courses, and certainly you will not be doing the same projects. So what we try to do is, we do have people with a lot of experience, 10 plus years of experience in the program right now. We may even get people with 20 years experience. So definitely there is a role for people with a lot of experience. Software experience would be great because AI does require a lot of software engineering. So someone who understands that world is going to be a very good fit for this program.
Correct. I have another question, very similar. This is from Jaideep Sinha. He's asking, he has a gap of 3 years. Uh, will he be able to join? I'm concerned which stream that he comes from, but he also wants to know how the entrance test works here.
The entrance process is that there is no test, there is no written test, there is an interview. This interview will be taken by one of the faculty, probably me, and you have to have a certain level of exposure to quantitative subjects in your undergraduate discipline. So if you have studied, purely arts type of background, then you are not going to be eligible. But many business administration or economics type courses have enough quantitative subjects to qualify, and obviously science or engineering graduates do qualify. If you have a gap in your resume, I don't think that is necessarily a deal breaker. We'll have to see exactly what happened, and you have to, at the interview we will go over what your background is. More important than your history is your aptitude, whether you are you have a computer skills, what kind of computer skills you have, whether you have mathematical aptitude, not mathematical knowledge, but mathematical aptitude. So we actually give you problems to solve during the interview and judge whether your aptitude is up to the mark.
Great. Okay, we are almost nearing the end of this session. In the interest of time, I would like to take one more question, and then we'll start wrapping up. Anirudh is asking, how much percentage of case studies are covered in this program specifically?
Uh, we we do have case studies. All the management courses have case studies. Some of the AI type courses also have case studies. We have two types of courses, three types, I would say. One is the core AI courses, one is the core management courses, and then there's the AI applied to management type courses. So we do have case studies in all of them, but our thinking is that in the case of AI applications, projects are even more important than case studies. So for instance, we will be teaching a course this semester on the importance of ethics in AI development. It's a very important topic right now. So for that, we are going to have a project and a case study. So there will be a case study of an actual, US-based event in the, that illustrates certain ethics issues. At the same time, you are going to have a software project that actually illustrates bias in AI systems and how to correct for bias in AI systems, which is a very, very important topic in AI right now. So we kind of think that the two things have to be combined. Our emphasis is on projects, but we do use case studies.
Great. Uh, that is all actually for today. I know we have a lot of questions that are unanswered, but with interest of time, we would not be able to take all of them. But I'm sure if you reach out to Dr. Debashish Guha over LinkedIn or just drop a query on their website, they'll be happy to take it up. Please read more about this course, and that will give you guys a more better understanding as to what all things that are involved, what is the curriculum, and how it can make a difference in your AI career. But for now, thank you so much, Dr. Debashish Guha. It is indeed a great session, and I hope the audience had a good understanding of how they can build their AI career and what role SP Jain's Master of AI in Business can play. So thank you so much for participating, Dr. Guho, Kiran, and the entire audience.
Thank you very much. Thank you for inviting us, and thank you for your very able guidance throughout this session personally. And thanks to Analytics India for inviting us to present this. And to the participants in this, please feel free to reach out to me. And if you have questions, that we didn't have time to answer, you can direct them to me, and I will try and my best to address them. Thank you again.
Great. Thank you, Dr. Goho. Thank you.